Okay. Welcome everyone to our career talk on AI and games. So I'm going to let the guest speaker introduce himself and talk now.
All right, great. Thank you, everyone. I'm Julian Togelius, and I'm going to share screen here, and I have a couple of slides. Good. So, as I said, I'm Julian Togelius, and I'm an associate professor at New York University in computer science. I'm also a co-founder of a company called Model.ai, which is a game AI startup out of Copenhagen. So I wear two hats at least in this case. Um, a little bit of myself before we launch into this. So the accent you hear here is a Swedish accent. I grew up in Malmö in the south of Sweden. And I went to high school there and I managed to finish high school, even though I almost failed the math classes. And when I went to university in Lund in Sweden, I decided that, I will never do anything involving maths. Absolutely not engineering. Engineering sounds like the worst thing, the most boring thing. I care about understanding the mind. I wanted to be a philosopher, so I studied philosophy and I studied psychology so I could understand the mind. Then I realized that actually, if I want to understand the mind properly, I need to build minds. So I gradually segued into artificial intelligence. I'm one of the people that had self-taught myself programming before. It's interesting, you can be very good at programming without being good at math, I've discovered. So I did a master's in University of Sussex in the UK, and then a PhD at University of Essex, also in England. And I wanted to work on using evolutionary computation, so Darwinian evolution, to create neural networks of controlled robots. I did it for a bit and I discovered this was too slow and I didn't have the patience for that. So I switched to training agents inside video games. And around that time, I also realized that, actually training agents that play games is all fun and great. But what about creating agents that make games? So that became kind of what I did. I did a postdoc after that in Lugano in Switzerland with the famous machine learning professor Jürgen Schmidhuber. And then I worked in Copenhagen, at that University of Copenhagen, and now at New York University. And my path is essentially from philosophy and psychology to artificial intelligence, applied to robotics to games. And yeah, it's a lot of fun. We have very little time here, so I'm gonna give you a quick dip into the kind of things I do, and then we can perhaps discuss more later on. So artificial intelligence. First of all, what is artificial intelligence? And when you talk about this, there's a lot of concepts straight out of sci-fi coming out, like, oh, it's these robots that think for themselves and perhaps take over the world and so on. This red eye-like thing is from the movie 2001: A Space Odyssey, which is one of these classic movies about AI takeover. It's a movie from 1964, I think, 1968, something like this. And it's a super classic. You should watch it. But beyond all these things, I think the simplest definition we have of what artificial intelligence is making computers able to do things which currently only humans can do. This is kind of what we do in AI. We find something that humans can do, but computers cannot do, and then we figure out how computers can do them. So what do humans do with games? Think about this for a minute. No, not a minute. Think of this for 10 seconds. What do humans do with games? Make a list. Okay. So the most common thing that almost everyone answers the first time is to play them. Of course, you play games. But also humans make games. They design games. They make art for games. They test games. They write about games. They make game levels for themselves and for others. They mod games. They interact inside them. They chat. They do all kinds of stuff. So basically, you can do a lot of things with games, and all of these is kind of an AI problem. AI for playing games tend to get all the attention, But actually, AI for understanding games, AI for building content for games, AI for designing and developing games are like at least as big challenges, if not, I mean, even bigger. And interestingly, it all kind of fits together. So to start from playing games, there's been this movement for a while for like using video games as AI testbeds and benchmarks. There's been a lot of work using versions of Super Mario Bros. And I'm partly responsible for this because I introduced one of these important benchmarks here based on Super Mario Bros. There's been a lot of work in StarCraft, on various racing games, and on first-person shooters of various kinds. Oops, sorry, this one had sound on. So this is what happened back in 2009. Notch, the guy who did Minecraft, who developed Minecraft, before he developed Minecraft and became all weird, before that he developed this public domain, open source version of Super Mario Bros. And me and my student back in Switzerland decided to turn this into an AI benchmark. And we released this online. And I know you're just looking at this and like, wow, this guy is playing so well, right? Release this online as a competition, and people submitted the best agents. And some of the agents were extremely good, such as this one you see here. This came out like a week before the competition deadline. And you see what he did there? That's kind of crazy, you know. No human can do those wall jumps, not as far as we know of. This guy submitted an agent that was basically to us seemed to play perfectly. And we were a little bit sad. We were impressed, of course, but we was a little bit sad because was the competition really that easy? Would they just win this? Was this not an interesting AI problem playing this game after all? And then we wondered, what is this kind of agent? Is this some kind of massive neural network, some kind of state-of-the-art amazing AI method? But it turns out no. What this did here is a kind of planning algorithm called A*, which if you study computer science, you learn about this in your first or second year. It's an agent that finds shortest paths, and you can implement it in, 30 lines of code maybe. And it basically planned paths, and it simulated the game forward so as to find paths that avoided various enemies and won the levels. So this was interesting. So we thought hard about this and realized, can we make the problem harder? So we designed a new level generator that generated new, harder Super Mario Bros. Levels. So this is from the 2010 edition. What you see here is the same agent you saw before, running into basically a dead end here, cul-de-sac. And because of the characteristics of this agent, it is trying hard to get out, but it can't really get anywhere. But everything it would need to do would be to go back and jump up on top of it. So here, for example, it's doing all these crazy jumps, but it never really even once figures out that it needs to go all the way back and jump up on top of this in the cave here. And there's more really fascinating examples later on. This one I like particularly. Here, the Mario is stuck with this little sort of, the spiky guy. And it's like he's dancing with him. He does amazing micro, but he doesn't have any macro. He doesn't realize he needs to go back and go above here. And of course, so because we made the problem harder, people would come up with ways of coming up with better solutions. So here is an agent called Realm, which was developed for this competition. It nicely overcomes the limitations of the previous agent because it works on multiple levels. It has a rule set for where to look in the level and where to go. These rules are evolved using evolutionary computation, which we'll get to a little bit what that is, and it and then it executes them using an A* agent. So it's a quite complex system, and it's an interesting thing to take away here is that the nature of a problem can vary a lot, and a solution to a very particular form of a problem might be very narrow, very brittle, and then you can sort of change the problem up and you need to come up with a new solution. This is how a lot of AI research happens. Another problem is playing the game as well as possible, even the right problem you're trying to solve. So this is from a former postdoc of us who trained agents to behave like humans. So this is she trained this on her nephew who was 5 years old at some point, and basically trained a neural network to behave like this guy. And then we ran this competition where we asked people to watch various videos of Mario being played by AI systems, by humans, and asked them who is the human, who is the AI. And the one that could fool the most humans was the winner. So that's a completely sort of orthogonal problem to playing it well. All right, so there's also a lot of discussion about generality in artificial intelligence. So I just give you a quick taste on this in Super Mario Bros. Because Super Mario Bros. Is easy to explain. But there's been a lot of research on coming up with agents to play particular games, even particular levels for particular games. What about playing many games? Can you construct agents that can have some kind of generality? So we came up with this thing called the General Video Game Playing Competition, which is a joint interface for what is now about 160 games, which are two-dimensional games like on old game consoles. And it basically lets these submitted agents play these games that it hasn't seen before. So they're secret to the submitters, and scores them. So here is, for example, a remake of the part of the overworld in Zelda in the 2D form. You have to basically kill these monsters, get the key, get to the door, and make your way out of here. And it turns out that this is not super hard, but it's not trivial either. A random agent that just takes random actions is very bad. It dies immediately. A human will have to work a little bit about this. Oh no, this is not a human. Right, we saw a human. This is a search algorithm called open loop expecting max tree search, based in turn on another algorithm called the Monte Carlo tree search, which is a pretty complex agent. And this actually did pretty well. And here is a very different game called Boulderdash, which is played by the very same agent. The nice thing here is that the very same agent can play both games, and it can play any game after these 160. But some are harder than others, so it only wins reliably on about half of them. So this is a way which games really help AI research as well. You can create this interesting test benches, and you can test your algorithms, and you can develop your algorithms that are better at these games. And if it's not one game, but a whole set of games, you're kind of increasing their general capability. Now, turning the problem around a bit, how about creating games instead of playing games? So throughout the history of games, there are lots of games that basically include some form of procedural content generation, which means that some part of the game is developed by the game itself algorithmically as it is being played. And this includes things like Elite, which is a game from 1984, which has 4,096 different star systems you can fly to, you can trade, you can do missions, you can get into fights with other spaceships and so on. And it runs within 64,000 bytes. So the old computers that it could run on, like the Commodore 64, had literally 1,000,000 times less memory than a modern computer. And how could it have this huge star system inside? Because every time you arrived at a new place, it generated this system algorithmically. And there are a lot of games that are built on this in various ways. The Diablo series, Diablo 3 is a bit old now, but Diablo 4, I think, is out in beta. It's built on like regenerating the different environments you run into all the time. Spelunky, this indie platformer game, is very hard, very interesting, also regenerating things. The whole Civilization series of games has the same thing. Every time you start playing a game, you have a completely new world map with new civilizations in different places that you sort of are that you will discover as you play it. And things like No Man's Sky, which is, it might not be the most fun game and it's not the most commercially successful game, but it was a big thing when it came out in 2016 and I kept working on it. I can recommend trying it. It's very, very ambitious in what it generates because there are literally billions of planets in there, and every planet is actually unique and generated. It has unique fauna, unique flora, unique geology, it's unique everything. And we're not going to dig into like the intricacies how this is done. I'm just going to give you a quick taste about this. So we go back to Super Mario Bros. Because Super Mario Bros. Is so easy to work with and easy to illustrate things in. So one method that's been used a lot, and is a kind of method that I've been working a lot with here, is evolutionary computation. If you've heard about genetic algorithms, that one form of evolutionary computation, what happens here is that you're mimicking Darwinian evolution in nature by having a lot of random solutions. So that basically, if your solution has two different parameters, we can call them genes. This describes the two axes here, x and y, and then z here describes how good a solution is. And we simply generate a lot of random solutions and remove the bad ones, let the good ones stay, and let them reproduce. Basically, you let them have sex with each other. You basically have offspring from them, and then which less interestingly means that you're basically doing the intermediate value between the good solutions. And then you add some randomness, and what happens in this kind of seemingly undirected weird process is that generally the good solutions, it centers around the good solution, you get the selection pressure, and you find good values. So it's an optimization algorithm. So here we do this for Super Mario Bros. There's a way you can think of Super Mario Bros. As basically long strings, the Super Mario Bros. Levels. Basically that here is like slice one again, slice two, slice one again, slice three, and then you basically, this becomes a string that says 1, 1, 2, 1, 3, etc. And you can basically evolve those. And you evolve those to find as many patterns as possible, like patterns like different paths you can take, enemies, trapped, and so on. And that way you can automatically generate an infinite amount of new Mario levels that have the right kind of structure. You can also control this in various ways, like tell it like, oh, I want a new Super Mario Bros. Level that is like easy at the beginning, then it has a lot of enemy challenges, and then it has jump challenges and things like this. So you can sort of direct this in some way. Which makes you wonder, well, if the AI can design a level, what do I do? Well, you collaborate, you do it together. So this is a game called Cut the Rope that was popular on mobile maybe 10 years ago or something, where you basically need to find a way to feed this candy to the frog monster down here. So we developed with my former research lab a system that could automatically generate these levels. It basically finds automatically playable levels in different ways. And then you basically can also build them by hand. So this is like a research interface where you can put up a new rope, and it simulates the physics a bit. The candy here bounces around a bit. You put up these bumpers, which are like flipper bumpers, cushions, which you can blow and sort of push the candy in some directions, bubbles, which can fly on rockets and so on. And then the system automatically tests this level. Is this level good? Oh, it's playable. And it shows you how to play it. You see up here, it tells you exactly what to do and at what time, and plays the level for you. And this is nice because basically then you can automatically test things you build. So the system kind of collaborates with you. And here it's like, you can look at all the actions it took, the actions it could have taken. Then you can say that, okay, thank you for testing my level. Now I want to actually keep some parts of the level. These are the parts I want to keep. Now please regenerate the rest. Okay, nice. How does this play? This is a weird one. This was a pretty boring level because you just need to cut all the groups at the same time, or almost the same time, and the candy falls into the frog. Now here, let's do a new one. And it finds a pretty strange solution to this one, where the candy goes into the rocket and then bounces off the bumper into the mouth of the frog here. The key thing here is that you have this two-way flow of control where you are taking actions and the AI system is evaluating the levels you're building, and it's also helping you build new things. You can tell it like, hey, redo this part in different ways. Right. So as not to sort of go on for too long, just some like summarizing words. So basically, video games are great testbeds for AI research. So you can use video games to develop new AI algorithms, because they're cheap and varied and much cheaper than robots and faster than robots and so on. And they're designed to challenge your mind. Basically, game design. What game design does is figuring out new interesting problems for humans to solve. And we play games partly because it challenges us in different ways. So this is why game designers have been spending a long time like finding new interesting challenges that we humans find interesting, and that's why they're interesting to train agents on. Now, general video game playing is even more important, trying to come up with AI that can play not one, but lots of them. But then you can also talk about AI. AI is everywhere these days. But also for game design and game development, AI is the future, basically humans collaborating with AI. Testing games, which is what this company I've started is doing, generating content together with humans on its own, generating characters, quests, landscapes, levels, everything, generating tutorials for games, and so on. There's a lot of stuff I didn't go into here. This is like a whirlwind blaze into this world. Right. And if you're interested in this field, I've written this popular science book called Playing Smart. I wrote it so that my parents would understand what I do, and they read it. I hope they understand what I do. This is a short and easy read, and I can recommend it. I'm biased. And then we have this textbook called Artificial Intelligence in Games. We also run a summer school associated with all this. But yeah, if you're interested in this field, I would recommend starting here and reading up on this book. And then there's tons of stuff you can do online to try things out. And with that, I'm gonna stop sharing and hand it back to you, Katie.
Okay, thank you so much for the presentation, and can I ask you one final question about your job?
Yeah.
So, do you have any advice for high schoolers who might want to pursue AI and game development?
Yeah. So by all means, get a relevant degree. And a computer science degree can never go wrong. You don't have to have a computer science degree, but try to sort of learn programming to start with. A good way to do that and to do it in a systematic way and get to the depths of it is getting a computer science degree, but you don't have to do that. The game development world works it's very important to have a portfolio, to have something that shows what you can do, so that when a recruiter sort of asks you, interviews you, you need to point to like, hey, these are things I did. And often this would be your actual code for various program and projects you did. There's a lot you can engage with online. If you go to the IEEE conference on games, So IEEE COG, COG. There is a lot of competitions you can get started with and try to participate in. And there's a lot of open source software. If you already know how to program, that's great. Otherwise, learn some Python and then learn a deep learning framework such as PyTorch. And then there's a lot of open source software online. I would also recommend reading my book, but I'm biased.
All right, thank you.
Thanks.
So, thank you so much for the presentation again. And yeah.